Hi, it's Liz Sneddon here. Let's have a look at confidence intervals and sample size. So we want to think about what happens when our sample size increases. So the more data I've got, the more information, the more accurate and reliable any results are going to be from that information. So think about that in terms of the sample size. Sample size is getting bigger. So if we get a bigger sample size, think about the interquartile range, so the width of the box. That width of the box is going to get narrower as we get a larger sample size because we're getting data, we're getting estimates that are more precise. So that means my confidence intervals are also getting more precise. I'm more accurate with my estimate of where the population median will be. So if we think about what that means, look at these widths, look how wide they are, and you'll notice that they get narrower as our sample size increases. So let's have a look at an example of calculating a confidence interval. So if I've got an interquartile range of 1, sample size n of 10 and a median of 10, we've got our formula, which is our median plus or minus the margin of error. So in full, the margin of error part is 1.5 times the interquartile range divided by the square root of the sample size n. So we're going to substitute those values in. So in place of the median, we put 10, in place of the interquartile range we put 1, and in place of the sample size n I put 10. So let's calculate that. So if I just do the 1.5 times 1 divided by square root of 10, that's going to give me a value of 0.4743. Now I want to split this, that plus or minus means split it into two calculations. So I'm going to get two parts. So I'm going to put this in brackets because it's a range, it's our set notation, and I want the smaller number on the left and the bigger number on the right. So I'm going to do 10 take away 0.4743 and 10 plus 0.4743. So that's what the plus and minus sign means. When I calculate those two numbers, that gives me a range there of 9.5257 and 10.4743. So in terms of what this actually looks like, so think of a number line. This would be a confidence interval between those two values. So that's what the calculation does, is it calculates where that confidence interval would lie. Now I want you to think about what happens to our accuracy and reliability as our sample size increases. And from this animation here, thank you to Chris Wild from the University of Auckland, I want you to think about the top one and look at the blue lines. So the blue lines that are being left behind, those are our medians. And look at how wide the range of that is. Then I want you to look at for the second one with a sample size of 100. You'll notice that those blue lines are not quite as spread out. Then when we get to the third one of 1,000, you'll notice that blue band is narrower again. And so this is that same idea. As our sample size increases, our confidence intervals become more accurate, more reliable, because we've got more information. Thanks very much for watching.